So, hello all, welcome to the IIT Gate classes. In this session, we are going to discuss the solution of Gate 2025, and in that, we are going to discuss the structure part solutions. Now, coming to the weightage part, here, if you see the section B, we have aircraft structures. In this one, if you see the total number of questions that were asked, total number of questions were 12. Out of that, 5 questions were there of 1 marks and 7 questions were there of 2 marks. And the total weightage for this subject is around 19 marks. Now coming to the weightage, so it is quite good weightage for this aircraft structure in this particular 2025 session. Now moving on to the question number 1, as some of the questions, most of the questions already we discussed in our immediately after the gate examination conducted. Once again, we are discussing detailed solutions this particular gate 2025. If you see the question number 1, that is question number 26, according to your paper, for a homogeneous isotropic material, the relation between the Shear modulus, Young's modulus, and Poisson ratio will be what? So we have discussed in the class that the relationship between elastic constant, that is we have the 4 elastic constant for a homogeneous and isotropic material. What are all those 4 elastic constant? Here we have E, K, Z, mu, right? So these are the 4 elastic constant we have. Out of that, we have 2 independent elastic constant, because other can be determined very easily if you know the 2 elastic constant. Like if you know the relationship between E, Z and mu, E that is equal to 2Z, 1 plus mu. So if you see, if you know E value and if you know the Poisson ratio, you can easily determine Z, right? E by 2, 1 plus mu. You can get it from here directly if you know E and mu. Or if you know E, Z, you can determine the Poisson ratio. Out of 4 elastic constant which is being mentioned for homogeneous and isotropic material, right? This is ideal material. For this material, that is one of the basic assumptions we are considering before starting our subjects, right? So for this homogeneous and isotropic material, we have 4 in total elastic constant. Out of that, the 2 independent elastic constant we have, either E or Poisson ratio, or if you have any 2 from this particular 4 elastic constant. So what is the correct option? C will be the correct option, right? According to this relationship between EZ and mu, we have C as a correct answer. Can you please check it out? If any doubt, you can just mention in the chat section. Now, moving on to the next, that is a question number 27. They have given the uniform varying load, which is varying from maximum intensity Q naught at the support A and 0 at the support B. A simply supported horizontal beam is subjected to distributed transverse load, which is varying from Q naught at 0 to the 0 Q naught at A and 0 at B. Which of the following options are correct? Now if you see the option, here we have the figure along with the options. In the option A, what they have mentioned, the magnitude of the vertical reaction force at A is larger than that of B. Second option, they have mentioned the magnitude of the vertical reaction force at B is larger than that of A. In the third option, they have mentioned the magnitudes of the vertical reaction force at A and B are equal. And D, they have mentioned the reactions at point A and B are indeterminate. So before coming to the solutions, here you can directly eliminate D and C, right? Because it is not a uniformly distributed load, right? It is not a uniformly, a constant load where each and every section having subjected to what? Same intensity of the load, right? So C cannot be correct answer and D cannot be correct because we can easily determine this simply supported beam comes under what? Determinate beams. So we can easily determine the reaction from the static equilibrium equations. Now coming to the options A and B, for that we need to solve it from the static equilibrium equations. If you see the solution part, first we will try to make the figure that is a simply supported beam. Here you have a simply supported beam where there is a hinge support and at one side we have a roller support. And if you see the variations of the load, it is given uniformly varying load. Uniformly varying load. Which is varying from Q naught at A and 0 at B. And it is having a length of L. First of all, we know the static equilibrium equations. What are all the reaction forces will be coming? What are all the reaction forces will be coming, right? So if you see the reaction forces here, if I just show the reaction forces, one will be there is a vertical reaction force, that is RAV will be coming, and there is a horizontal reaction force will be coming, and here there will be RBV will be coming. Only RB will be there because it is a roller support, so there is no horizontal reaction force. So first is static equilibrium equation. We have summation of force in x direction is 0. If you consider the coordinate x, y, z, and I'm considering the beam to be in xy plane, then summation of force in x direction to be 0. Then there is no external forces in the horizontal direction, so this reaction force at A in the horizontal direction will be 0. Now summation of force in the y direction to be 0. That is the second equilibrium equations. We are considering upward direction force as a positive, then RAV plus RB minus half of what is the total load, equivalent total load for this uniformly varying load, which is supposed to be act somewhere here at a distance L by 3 from the support A. What is the value? Half of Q naught into L. That is equal to 0. So this is what we are having. The first equations RAV plus RB, that is equal to half of Q naught into L. We may not need this equation, but I'm just mentioning it for the reference. Then we can also directly calculate the reaction forces from third equilibrium equation, summation of moment about any point to be 0. Let me take the moment about A to be 0, and I'm considering the clockwise moment as positive. Then this half of Q naught into L, this will be acting at a distance of L by 3 from this particular support A. Then half of Q naught into L by 3, it is acting in the clockwise directions because this, if you take the moment, it is acting in the clockwise directions, minus RB into L, that is equal to 0. If you calculate RB, you are going to get Q naught L upon 6. So this is what we are having. This is what we are having the value for RB. Now we need to calculate the RAV also. Again from the equation number 1. RAV will be half of Q naught into L minus RB. RB is Q naught into L upon 6, which will be giving you Q naught into L upon 3. If you compare RAV and RB, definitely RAV is what? Greater than RB. So what is the correct answer for this question? The correct answer will be A. The magnitude of the vertical reaction force at A is larger than that of B. Please see the solution. If any doubt, you can mention in the chat section. Okay, moving on to the next question. Now, if you read the problem, the stress field is given by sigma xx and sigma zz, that is equal to C1 y. Sigma yy they have given C2 into y. Then tau xy, tau yz, and tau zx, that is the shear stress value they have given as it as 0. C1, C2 non-zero constant. If the stress field satisfy the equilibrium equations, which of the following options are correct? The first option they have mentioned, there is a no body force per unit volume. There is a constant body force per unit volume in the y directions, and the body force per unit volume varies linearly in the y directions. The direction of a body force per unit volume depends on the values of C1. For that, we need to first of all write down the equilibrium equations, 2D equilibrium equations. That is, they have given okay, sigma xx they have given, sigma zz they have given C1 into y, sigma yy they have given C2 into y, tau xy, tau yz, and tau zx they have given it as 0. Let me consider the body force per unit volume in the x direction Fx, in the y direction Fy. Then what we can write? These are the body force in x direction and y direction respectively per unit volume. Again from equilibrium equations, what we can write? Dou sigma xx upon dou x, dou sigma xx upon dou x, dou tau xy upon dou y, dou tau xz upon dou z plus f of x, fx that is equal to 0. If you put into these equations, what is the dou sigma xx upon dou x? It is not a function of x, so it is 0. Tau xy is 0, so this term automatically will be 0. Tau x is 0, so this term will automatically 0, and this term is also 0. So what is the body force in x direction? It is 0. But they are asking the body force in y directions, so we need to write down the equilibrium equations in y directions. That is dou sigma yy, dou sigma yy upon dou y, dou y, dou tau yx upon dou x dou tau yz upon dou z plus fy that is equal to 0. Dou sigma yy upon dou y will be what? C2. So this term will be C2. Dou tau x, so this term is 0 because tau x is 0. Tau yz is also 0, so this term will be 0. Plus fy that is equal to 0. So what is the fy value? It is minus C2. So here we are getting the a constant body force per unit volume in the y directions. So which of the following options are correct? B will be the correct. B will be the correct answer for this question. So again, it is a straightforward question from the equilibrium equations. If any doubt, you can ask. Yes, yes, Sasan, you are correct. That uniformly varying load, where there is a more load, it has to basically resisted by maximum has to be resisted by the particular left support only, because left in the left portion there is a maximum intensity of the loads are there. So definitely Ra will be more than Rb, but still for confirmation and for purity purpose we need to solve it. But for saving time, very quickly in a quick time you can answer it. Now moving on to the next question, that is question number 29. A uniform symmetric cross-section cantilever beam of length L is subjected to a transverse force P at the free end, as shown in the figure. Young's modulus is given as E, moment of inertia is given as I. Ignoring the contributions due to the transverse shear, the strain energy stored in the beam is what? The strain energy stored in the beam is what? So there will be strain energy because of shear load also. Because of this transverse shear, there will be shear strain energy, but that we need to ignore it. We need to consider the whatever the strain energy is stored because of bending, right? So it is a very, very important thing. Now, coming to the solution part, there is a cantilever beam. And there is a load which is acting at the free end of the beam, and it is having a length L. First of all, what is the strain energy because of bending, which is represented by the U? So strain energy, I am representing it by the simple U. So we know the formula, that is 0 to L mxx square dx upon 2 EI, where EI is nothing but flexural rigidity. Now, what is the bending moment at a section XX? So first we need to consider this section. I am considering this section here at a distance of x. So what is the bending moment which is acting at this section from the right side? So that is a hogging bending moment minus of p into what? X. So if you put the values here, 0 to L minus of p of x dx upon 2 EI, then p square x square dx upon 2 EI, 0 to L. p square upon 2ei, I can take it as common, and I can write x square dx, so that will give me x cube by 3, 0 to L, which will be further giving me p square LQ upon 6ei, that is the u of bending. So based on this, the correct answer will be A. Please check it out. There will be post-grade guidance will be given where the qualify marks and cutoff will be discussed separately. In this session, we are discussing the solutions of respective sections, which is being asked, right? Coming to the next question, if you have any doubt, you can ask me regarding this. Of course, in the class we have taken, we have discussed thoroughly that what could be the total strain energy if we consider the transverse shear load also, right? If you consider for this particular beam, there will be U because of shear load and U because of bending. But the contribution of shear load will be very small. So the correspondingly the strain energy will be stored because of shear load, that will also be very small as compared to the bending strain energy. That's why they are ignoring. But if at all they are asking along with the options, if they give some more particular thing, this would have been a tough numerical. But still, in particularly at IGC, we have discussed each and everything, every corner, that you can also see, through our next question, which we are going to discuss. Now, as I'm talking about this particular question, see, in the class also, we have taken basically one numerical where we have discussed, I have given one question where, if all of you can recall, that there was a square box where the diagonals were given like this, and if there is a some deformation will be there, then at a particular point E, at the junction of this diagonals, what will be the shear strain with respect to x and y axis? But they have given the x and y axis something like this. Here, if we try to recall this homework problem, I have discussed the solution also in the WhatsApp group. There, I asked that what will be the strain energy at E with respect to x and y, given x and y axis, right? And I stretched too much upon telling the thing that the shear strain calculation may be easy, but we need to be very careful. Whenever you are calculating shear strain, two things you need to observe. First, we will come to this question also, but I'm just telling you the very basic thing, and many of you may be able to recall. Already we have discussed that thing. That whenever we are taking the numerical of shear strain, we need to see at any particular point, you know, at a particular point, if they are asking shear strain, we need to see the line segment or edges along those particular, at that particular point. Let's suppose there is a rectangle sections, and x and y axis is given like this. At a particular point A, if they are asking series strain, let's say it is getting deformed, something like this. This plate is getting distorted, something like this. Where you can see this particular distortion from the edges along AB, which is along the y direction, and edge AC along x direction. Both are getting distorted, AC dash, and this will become what? AB dash. And these edges are there along x and y axis, right? So whatever the shear strain will be there at a particular point A, definitely it is the value corresponding to the given coordinate x and y axis. But this value at the same point it will change if I change my axis. Suppose if I will be changing the axis like this, instead of giving like this, if I just in the same problem which I am giving right now, just for the example number 1, if I change my axis, let us suppose I am changing my axis like this, x dash and y dash. At the same point A, x dash and y dash corresponding to x dash and y dash at the same point A, the shear strain will be different. So while discussing that homework problem, while giving the hint, I already discussed. On that particular basis, straight away this question is being framed out of that. So before coming to the solutions, the basic thing is that the shear strain at a particular point will change with respect to given, you know, it is basically given based on the directions or axis. If you change the coordinate system, definitely your answer will change for the engineering shear strain. That particular fundamental only they want to test it, right? And that's why they have given this particular question in 2 marks, not in 1 marks. If this question, this if the shape would have been different, or maybe if the question will be something like example number 1 where the coordinates are x and y, definitely they might have included this question in 1 mark. But extra weightage is given just to test the fundamental, right? And that too, they have given the option wise so that you do the blunder and get the negative marking of 0.67. Now coming to the solution, that's what the mentality I just said about the professor who said this question. Now coming to the solution. Now if you see the solution part, in the given figure, first of all, I'm drawing the figure that is a rhombus. If we take a square sections and if you tilt it by particularly, like this, if you tilt it by 45 degree, you will be getting the rhombus. Each and every sides are having the same length. So if you try to take it, assume it there is a basically 90-degree angles at each and every points of this particular sections, rhombus sections, where the naming is given as A, B, C, D. After distortion, after application of these shear loads, what is happening? It is getting distorted. It is getting distorted, something like this. And they have given the particularly coordinate system as x and y like this, x and y. The dimensions, initially it was 20 centimeter, it is getting reduced by 0.02 meter, or you can say 0.02 centimeter here, 0.02. All the particular what we call, all the units are in what, centimeters. So it is getting increased at B, it is getting increased by 0.02, and at A it is getting decreased by 0.02. Just check it out. Now so I'm just mentioning here 0.02, and it is getting increased by 0.02, and initially these particular dimensions are 20 centimeter. They are asking what is the shear strain at a particular point A. If you read the problem, what is the engineering shear strain? What is the engineering shear strain? Right? They are asking what is the engineering shear strain. You can take it as engineering shear strain at any particular corner. So either you can take A, B, C, D, whatever you want. You can take it at any particular corner. You can calculate what is the shear strain they are asking. Now, shear strain they are asking with respect to which coordinate system? They are asking with respect, and x and y. If you see, x-axis is what, horizontal, and y-axis is what, vertical. X-axis is what, horizontal, and y-axis is what, vertical, and x-axis is horizontal. What is the angle between these two particular axes? The angle between this particular axis is what? The angle between these two particular axes, given axis is what, 90 degree. And this angle between these two axes will not be getting changed even after deformations. Even after deformation, you can see the red color one is still x and y axis are making what? Angle of what? 90 degree. Right. So shear strain for a given coordinate system will be what? Straight away 0. As I mentioned in the previous session also, that if this particular axis would have been something like this, suppose at A we want to calculate, and they might have given the, suppose I'm drawing here, suppose they are giving me coordinate system like this, y axis and x axis like this. So initially it is 90 degree, but after deformation what is happening? After deformation what is happening? It is getting deformed to like this. It is getting deformed something like this. Now, what is the C's? Along this, whatever the A is there, that will become A dash. B will become what? B dash. Now, this AB will become what? A dash, B dash, which was there originally along Y axis. And whatever the C is there, the C become what? AC dash. Now, AC will become what? A dash, C dash. Now, what is the angle between these two edges which are there along Y and X axis? Now, it is more than what? 90 degree. Now, it is more than 90 degree. So definitely shear strain for this particular system at a point A will be what? Non-zero. So your answer for a particular corner, for a particular configuration will change if you change the coordinate, if you change the axis. So that particular fundamental thing only what they want to test it through this particular questions, right? Again, I'm mentioning that the answer will be 0 because x and y axis they are given as a horizontal and vertical, and the angle between these two is what? Angle between these two axes will remains 90 degree all the time, irrespective of the deformations. Irrespective of the deformation by define, right? Because if you take any segment, any line segment along this x and y axis, their angle will remain same 90 degree based on the given deformations. Based on the given deformation, whatever the red color deformation is there, if you take along x and y axis any line segment, and if you take the angle before deformation and after deformation, it will remain 90 degree. But if I change my x and y axis, suppose I have given like this is a separate question, question number 2. And then if you see the angle before deformation 90 degree, after deformation more than 90 degree, so it will be what? More than basically In fact, the shear strain for a point A is what? Negative. Because we are calculating initial angle minus final angle. And the final angle is what? More than initial angle. So it is what? Negative. Suppose if they are asking what is the shear strain at a point B for a given coordinate system, this one system, right? Then for B it is positive because initial angle is 90 degree, but the final angle is what? Less than 90 degree. So initial minus final, again it will give you positive quantity, but it is non-zero, right? So all these things we have discussed very thoroughly in the class also, and even I mentioned that in the class that you need not to follow anything beyond the class notes, especially for the strength of material. Each and every homework problem which I given, the questions will be there from that only, right? Because all those questions will be taken from the what standard textbook like Hebler or Geregudno. And the same goes for the IGC assignment also. That is a must for getting the good rank in the GATE examinations. So that is all about this particular questions, which was a good question. Now coming to the next question, guys, that is the question number 37. Now read this problem. A 1 meter long rod that need to be designed to support an axial tensile load P. Before moving to this question, if any doubt, we can take that out, that particular doubt also. If no doubt, then we can proceed to the next question, that is 1 meter long rod that is need to be designed to support an axial tensile load, right? We need to design a rod that need to be, subjected to what? Tensile load. Now, tensile load is given the value that is the more than weight of the rod. Now we need to select the material for this rod in such a way that its strength should be more. That means it can carry the maximum amount of tensile load. It can support the maximum tensile load before failure, right? Or without failure. And it should have a lowest weight of the rod. It should be lightweight and it should carry the what? Maximum tensile load. That means if I keep on applying the load value, it should not fail. It should give me satisfactory particular uses, satisfactory function of this particular rod. For that, they have given the four material alpha. If you see the material alpha, it is the lightest weight. It is the lightest weight. If you see the material alpha, right? Try to understand the physical significance of this question, why they have given the questions. Solution will be there, definitely, no doubt. But always try to understand, because see, GATE examination is over. Now this is the basically what the solution session. Here we can discuss in detail about the problem. Here we don't have any timer, so that we need to directly attack to the solution part. We need to understand thoroughly each and every corner of why this question has been framed, right? If you see the material alpha, so you need to be patient for having the solution of this question. I will discuss some theoretical understanding of this question, then we'll discuss the solutions. If you take the material alpha, they have given the density 2700. Out of four material, alpha, beta, gamma, delta, if you take the density part, the material alpha is what? Lightest weight. It is having the least density. Immediately, your gut feeling will say that I will go to the material alpha. But again, if you just think based on the last line that the lowest weight, because what is the weight? If you calculate the weight, that is mg. If you take the rod without applying the tensile load, the weight is what? Mg, which is supposed to act at the basically center of gravity of that particular rod. Mass is given as what? Volume into density into g. Volume is what? Area into L into what? Rho into z. Immediately you might be thinking that I will be basically taking least density material. I will be having what? Lightest weight, and I will be taking the option A. But it is incorrect. Because they are saying using the strength based failure criteria, we need to support an axial tensile load. If you are able to support more tensile load, it will be good for the design. It will be good for the basically, you know, where you are putting this rod in that application, it will be very very helpful if you can basically design a rod which can carry the maximum tensile load. So you need to see the yield strength of that material also. If you coming to the material alpha, you are having the yield strength as 270 only, which is least among all. So it make you not that much of tensile load, right? You cannot support that much of tensile load through this particular material alpha. So we need to see the combination of density and yield strength in such a way that the tensile load can be maximized. Whatever the carrying capacity of that particular rod, it can maximize, and it should have a lowest weight also. So for that, we need to see the combinations of this density versus yield strength. Now, how the solution will go? The solution will go something like this. Now, guys, here you are having the, I'm just drawing. Suppose we have a rod of certain diameter and it is subjected to centroidal load, let's say P. It can be alpha, beta, gamma, delta. It can be anyone. We need to see that. Based on the strength criteria, that we know that what is the value of the maximum load it can carry. Sigma max should be less than or equal to what? Yield strength of the material for avoiding the failure. So P by basically what we can get area, that is equal to what? Yield strength. For solving the problem, we are equating this one. So P can be written as yield strength into what? Area. That is the one thing we are having where to support, if you want to support maximum tensile load, you should have a maximum yield strength of the material. Then only you can able to carry the maximum tensile load. Otherwise, if you select a material which is having a less yield strength, you cannot carry, you cannot subject that rod to maximum tensile load. Suppose if we have the two rod, one can support 20 kilonewton and one can support 80 kilonewton. So 80 kilonewton will be having what? Better functionality. You can here in, unfortunately, by some means, by some external factor, if the load is goes beyond 20 kilonewton, like let's say 30 kilonewton, your material will fail. But if you design for maximum load, if you design for maximum load, that means you are going to take what? More and more amount of basically more and more material you are going to take. Of course, you are going to increase the weight of the component also, but we need to design in such a way that we need to select the lowest weight and it should basically survive for maximum tensile load, right? So that is what we need to think. Now, that is the one part where we are taking the uh, picture about what? Load value. Now coming to the weight part, weight they have given that I am representing by W, that is equal to mass into acceleration due to gravity. Mass is given as volume into density into G. Volume, we know that area into length into rho into Z. Then this is the weight value. Now if we take the P and W, if we take P and W, what you can have? If you just take this as equation number 1 and this as equation number 2, and if you take equation 1 by equation 2, what you can have? P by W, that is equal to what? Yield strength into area divided by area into L into rho into Z. So if you see this value, yield strength by rho L into Z. Now try to calculate for each and every material. For material alpha, I am calculating. Just calculate, then I will be telling you P by W for alpha. If you just calculate, what is the yield strength for alpha? It is given as 270. And density they have given 2700. The length and G value will same for all the material. They are telling that the length is what, 1 meter. Already they have decided length is what, 1 meter. So let us keep 1 into Z. So if we try to calculate what is the value, 0.1 upon Z. Then material beta. For material beta, if you try to calculate P by W, it is yield strength. What is the yield strength value? It is 900 by 4500 into Z. So it is 0.2 upon Z. For a material gamma, what is the P by W for gamma? Yield strength, they have given it as 520. And this value they have given 7800 into Z. If you try to calculate, it is what? 520 by 520 by 7800. So it is 0.067. 0.067 by Z. And for material delta, P by W for delta is what? This value is what? 540 by 9000 into Z. So which will give you 0.06 by Z. If you see the among all, you need to maximize the value of P and you need to lower the weight. That means overall you need to have larger value of this P by W. Which material is giving you the larger value for P by W? It is what? Material beta. Now coming to the material beta. So right answer is beta, but see why. Beta, if you see the beta, it is having density in a basically what? Third positions. So it is a not a lightest weight, but it is a lighter weight. No problem. But if you see the yield distance also, it is having what? Highest yield distance value. So it is basically fulfilling our criteria, right? For which purpose we are designing the rod? It should support the maximum tensile load and it should have a lowest weight of the rod. So beta is the material which will give the satisfactory results for what? For basically application where we need to use this rod, right? So B will be the correct answer for this question. If any doubt, we can discuss. If no doubt, we can move to the next question. Now see the question number 55. Now guys, what they have given in the question number 55, a 1 meter long rod of 1 centimeter by 1 centimeter cross section is subjected to an axial tensile force of 35 kilonewton. Young's modulus for this material is 70 gigapascal, and cross section of the deformed rod is 0.998 and 0.998 centimeter. The Poisson ratio of this material is what? So this is the answer for this question, but how we are getting this answer? A rod is there which is subjected to tensile load of 35 kilonewton, and it is basically having the cross sections something like this before deformations, but after application of the load, lateral deformations are something like this. It is getting elongated because of the tensile load, but if it's the lateral dimensions, it is getting what? Decreased. the lateral dimensions are getting decreased. The length of the rod is given as 1 meter. Now, what are the dimensions? 1 centimeter. Here it is 0.998 centimeter. Now, what is the value for, first of all, change in length? What is the value for change in length that we need to calculate? Poisson ratio. They are asking Poisson ratio, but how to calculate the Poisson ratio? Poisson ratio we can calculate that minus of lateral strain to the longitudinal strain. Lateral strain to the longitudinal strain. How to calculate the longitudinal strain? Whatever the direction you take, suppose I am taking x directions, along x direction, whatever the dimensions are there, whatever the changes are happening in that dimensions, that will give you longitudinal strain. So what is the longitudinal strain? We also call linear strain. We also call linear strain. That is change in length by original length. Change in length for a uniform strain all along these sections of this bar or rod, we can have PL upon AE. Then what is the value of delta L? PL upon A. What is the value of P? It is 35 into 1000 Newton. Length is what? 1 meter. So I can convert in mm. What is the area? Area was 1 centimeter by 1 centimeter. So it is 1 centimeter. We know that it is 10 mm. So it is 10 by 10. And Young's modulus, they have given 70 gigapascal. So it is 70 into 1000. So if you try to calculate the value, you will be getting 35 into 1000, 1000 by 10 by 10. So it is what? 5 mm. Now, moving to the lateral strain. Lateral strain, we know that change in lateral dimensions, change in lateral dimensions by original lateral dimensions. By original lateral dimensions. How the changes are happening in the particularly, if you see the along y and z directions, it is having same contraction. So I can write 0.998. I can write here final length minus initial length, but final, what are the final dimensions? 0.998, right? See, either you consider along the y, this one, or you consider this one. Both are getting shrink to what? Same value, that is 0.998 centimeter. That is the final dimensions, final lateral dimensions, right? So if it is 0.998, initial dimension is 1. Again, what are the original lateral dimensions? It is again 1. So what is the value here? 0.998 minus 1. So it will give you minus 2 into 10 power minus 3. Now if we write down the Poisson ratio value, that is minus of lateral strain to the linear strain or longitudinal strain. So minus minus will become plus, and the linear strain is what? It is 5 What is the linear strain? Delta L upon L. L is given as what? 1000. So it is 2 by 5, which is giving you the value as 0.4. So 0.4 is the correct answer for this question. Please try to see it. Now moving on to the next question. Now try to observe the question number 56. For a 3-bar truss loaded shown in the figure, the magnitude of the force in the horizontal bar AB is what? They are asking what is the value of the force in the horizontal member AB. Right. So this is a truss problem. The answer is given as 25. So again, I'm drawing this one. The horizontal load of 50 Newton is acting at, sorry, A here, BC. And there is a one is basically hinge support and another is a roller support. And the length is given as 1 meter for all the sides. Now if you consider angle between these, it is what, 60 degree. Now first of all, you need to calculate the reaction forces. So how we can make? Here there is a reaction force RV which is acting in the upward directions. At A there will be two reaction forces. One is a horizontal, other is a vertical. So I'm writing RAV and R. Suppose I'm writing here in these directions. RH. Now what you can do, summation of force in x direction you can take it as 0. So RAH value will be what? 50 Newton. 50 Newton. And then RB value, summation of force in the y direction to be 0. For that, what you can write? RB plus RAB, that is equal to 0 because there is no external force in the y directions. That is equation number 1. And then if I take summation of moment about A point to be 0, and you can take clockwise moment as a positive one, then RB into 1 anti-clockwise plus 50 into what? What is this value? This is 60. This is 1. What about this height? Y from the triangle? What is the sine 60? What is the value it is? Root 3 by 2. So it is what? Root 3 by 2. That is equal to what? 0. So what is the RB value? It is 25 into root 3 Newton. Once we know the RB value, it is very easy for us because now we can calculate by method of join. We have two methods for solving the truss problem for finding the force in any member. One is a method of joint, another is what? Method of section. I am discussing here method of joints. If you take a point B, there is a RB force which are acting as a reaction force in the upper directions. Let us take this force AB as a tensile one, and here it is compressive one, force BC. Because at the joints B, there is a three forces are coming: FAB, FBC, and RB value. FAB is what? Acting in the horizontal directions. FBC is acting what? Something like this. So this value is what? 60 degree. This value is 90 degree. What about overall this angle? It is 150. And this value is what? 120 degree. So again by sine rule, which I am discussing as the next one here, RB, FAB, and there is a basically FBC. RB we know 25 into root 3, because to calculate at a particular joint, if there is a three forces, one forces should be known. Then only you can calculate other two forces. What is the value? Here it is 90 degree, here it is 150, here it is 120. So by sine rule, if you take any force FAB, then you take sine of angle between other two forces. What is the sine of angle between other two forces? It is 150 degrees. So it is 150. If we take 25 into root 3, now what is the angle between other two forces? Angle between other two forces is 120 degree. So sine of 120. So what is the FAB? If you calculate 25 into root 3, sine 150. What is the sine 150 value? It is 1 upon 2. And what is the sine 120 value? Root 3 by 2. If you calculate, you are going to get 25 Newton plus. That means it is a tensile. Our assumed direction is correct. That means what? It is a tensile value. And what is the correct answer for this question? It is 25. Please take a look into this. Now moving on to the next question, that is a question from the vibrations. A uniform rigid bar of mass 3 kg is hinged at a point F, and it is supported by a spring of stiffness K, that is 100 Newton per meter, as shown in the figure. What is the natural frequency of the free vibrating system, of the free vibration of this particular system? So again, a simple problem is being asked from these vibrations. So what we need to do, first we need to take a system and we need to disturb the system, right? From the mean position, we need to disturb it. Without disturbance, there will not be any kind of vibrations. Now here, there is a spring force. There is a spring which is having a stiffness K, and the rod having a length of what? 1 meter. Mass is 3 kg. K value is what? 100 Newton per meter. And they are asking what is the natural frequency of the system. First of all, the moment you are taking the rod and you attach the spring, there will be static deflections will be there. In that static deflections, let's say the because of the static deflection, it is getting deformed. It is getting rotated by the amount theta, static, and it is deformed to this length. This is the value of length of the rod. The moment it is getting deformed, what are all the values which are acting? The weight which is acting in the downward directions. If you try to resolve the component of weight, it will be what? Mg cos theta, and this will be mg sin theta, theta s, mg sin theta s. And what is the initial spring force? The moment you if you take a horizontal rod and if you attach the spring, there is a static deflections. There is a static rotations, theta s, and because of that, there is a spring force will be getting generated. Spring force will be getting generated, FSI. Of course, this is basically a very large deformations, but actually the deformation is so small that we can ignore this particular part and we can take the system from here only. So there will be static. There will be initial spring force will also be getting developed. Now, if you take the moment, this is the F and G point. Now, if you at the same static equilibrium condition at the mean positions, what are the mg cos theta s into distance? What are the distance? It is half. That is balancing by what? FSI. FSI into what? Length 1 meter. 1 meter. In a limit theta tending to 0, in the limit theta s tending to 0, what is the sine theta? Theta s by theta s, it is 1. So what is the limit theta s tending to 0? What is the sine theta s? It is theta s. In a limit theta s tending to 0, what is the cos theta s? It is 1, because cos 0, 1. Same if you try to apply mg into what? 1 upon 2, that is equal to fsi into 1. So that is our equation number 1. You try to remember these equations. After the rod is attaining the equilibrium positions from here to here, this is my mean positions. This is the theta s. After this only, we are further displacing it by the amount theta. We are further disturbing it. But theta s is so small value. It is a very small value, such that you can ignore it, and you can think that the mean position is what? Mean position is not this one. The mean position is horizontal position only, and from there only, we are hypothetically assuming that we are disturbing it like this by the amount theta. So from again there, I am just moving to the solution part, that I am taking this mean position as a horizontal only, and I am disturbing it like this. Again, I am exaggerating because all the rotations, all the deformation in vibrations in strength of materials are considered to be very small, right? They are not. These subjects are not designed for very large deformation, large rotations. So again, we can take it as this value. There is a mg weight which are acting in the downward directions. This will be mg cos theta. This will be mg sin theta. Again, there will be spring force, which is nothing but fs plus fsi, because initially some spring force is there. Additionally, you are displacing it, so another spring force will be coming into the picture, fs, which is equal to what? Fs is equal to k in terms of y, where y is equal to what? Directly you can take it as L into theta. Suppose L is given as 1 meter, but I am writing it as L into theta. Actually, you should write y is equal to L sin theta, but theta tending to 0, sin theta will become what? Theta. Now again, you have disturbed the system in the clockwise directions. So again, apply the Newton's second law. Net torque about point F is what? I into alpha. In the clockwise direction, you have rotated it. But what are the spring force which are acting in the anti-clockwise directions? So minus Fs plus Fsi into distance. What is the distance? Suppose this is a L. Plus mg cos theta into what? L by 2. Mg cos theta. Theta tending to 0, cos theta will become what? 1. So mg into what? L by 2. That is equal to what? I about F. What is the mass moment of inertia about the hinge point, which is at the one end? It is ml square upon 3 for the rod. Alpha I can write theta double dot. Now from the equation number 1, we know that it is what? For example, if I take L. So from equation number 1, you know that this mg L upon 2 and this fsi will be cancelled out. So only I left with the what? Fs into what? L. That is equal to ml square upon 3 into theta double dot. Fs is nothing but given as minus k times of y. Y is given as what? L into theta into L, ml square upon 3 into theta double dot. So ml square upon 3 theta double dot plus k L square into theta, that is equal to 0. So theta double dot plus k L square upon ml square upon 3 theta, that is equal to 0. If you compare this equation with our standard equation for simple harmonic functions, and if you compare this equation and these equations, you will be getting what? Omega n, which is equal to what? K L square upon ml square upon 3, which is giving you 3k upon m, which is nothing but 3k. What is the value of k? It is 100. And m is given as 3, which is giving you the values 10 radian per second. Please make a note of it, or try it. If you have any other doubt, you can just mention in the chat sections. Now again, you can solve this question within 2 steps also. Directly you can start from here, you can disturb the system, you can get the answer. But that is not the methodology we follow at IGC, because we used to discuss each and every solution in detail, so that in future also you might be writing further GATE examination also next year also. If new question will be, not feel any lacking in the concept that you are able to solve the previous question but you are not able to solve the next question. That should not happen actually in the GATE examination. That is allowed in some other examination, but in GATE examination you should be clear from every corner. If you missed any corner, they will be putting the question from there only. This question seems to be easy, but we can make this question, same question, by just giving 90 degree, right? We can frame at least 2 to 3 problems from given particular problem, that too challenging problem. So that's why I'm saying that each and everything are required. Why mg torque is not coming, that is what being discussed, right? That is the first thing. Second thing, we have discussed theta s, right? Static rotations, which seems to be small. That's why the mean positions we have taken in a horizontal wise. In GATE examinations, they may also give that they can give that there is a no static. They can mention in the statement in the same problem that do not ignore the static rotations. That means there is a no static rotations in the system. Suppose in the same problem with the give, there is a no static rotations. Then again mg torque will be coming into the picture. In a final vibratory equation, angular vibration, there will be mg torque will also be coming here. Mg torque will also be coming. That's why each and every explanations are very, very important. You cannot ignore it. As simple as that. Now, coming to the next question, that is from the columns. A prismatic vertical column of a cross section which is given as a by 0.5 a, and the length that is equal to L is rigidly fixed at bottom and the free at the top. The compressive force P is applied along the centroidal axis at the top surface. The Young's modulus of the material is 200 gigapascal, and the uniaxial yield stress is given as 400 megapascal. If the critical value of P for the yielding and for buckling are equal, then what is the value of L upon A? Now, we can see the solution part. Again, answers are there in front of you. If you see the solution, that they have given the buckling load. Now, what is the buckling load? If I take the rod, just I'm taking the front portion and I'm applying the compressive load. What is the buckling load? Euler's buckling load. Pi square EI minimum. Pi square EI minimum by K L square. Now, for a fixed and free, it is a fixed and free column. For a fixed and free column, K value is taken as basically 2. Then what is the buckling load we can write? Pi square EI minimum by 4L square. They have given the cross sections dimensions as it is 0.5 A and it is A. This is YY, this is XX for example. What are the IXX? It is 0.5 A, AQ upon 12. And what is the IYY? It is very simple to remember. IYY means the dimension which are parallel to y-axis, I will be writing A, and perpendicular dimension will be Q. Out of this, if you take what is the minimum value, the minimum value will be what? This is I minimum. That is what we are writing here. Pi square E, I minimum is what? IYY, which I am writing A into 0.5 AQ by 12 by 4 L square. Then further what we can write? This buckling load, which that need to be equated to what? The load which is required for yielding. That is a very simple yield strength into area. Yield strength into area. But in the problem they have given what? What is the yield strength? 400 megapascal. 400 into what? Area. What is the area? 0.5 into 1 into what? A square. 0.5 A into what? A. Both need to be equated. This one and this one. If you equate pi square E, I is what? 0.5 A power 4 by 48 L square. That is equal to 400 into 0.5 into A square. Now put the values of E, 200 gigapascal, so it is 200 into 1000 megapascal, 0.5 cube A to the power 4 by 48 L square, which is equal to 400 into 0.5 into A square. Now they are asking what is the L upon A. What is the L upon A from here? If you take this under root of that, pi square into 200 into 1000 into 0.5 cube by 48 by 400. It is giving me the value as 5.07. 5.07 as a correct answer for this question. Take a note of it. Now moving on to the next question. A thin flat plate is subjected to stresses sigma xx, sigma yy, and tau xy. The factor of safety is defined as the ratio of yield stress to the applied stress. Yield strength of the material is given as 250 megapascal. The factor of safety for the plate, assuming the material failure is governed by the von Mises criteria. What is the value of factor of safety they are asking? Wait, the answer is there in front of you. So this question again, you should be knowing the formula for a von Mises equivalent stress. What are the von Mises equivalent stress? Yield strength divided by factor of safety from the von Mises criteria. Half will be common. Sigma xx minus sigma yy whole square. Sigma yy minus sigma zz whole square. Sigma zz minus sigma xx whole square. Plus 6 tau xy square, tau yz square plus tau zx square. Bracket close. In the problem, they have not given anything regarding sigma zz, that is 0. Sigma zz, that is 0. Tau yz is 0. Tau zx is 0. They have given tau xy, sigma xx, and sigma yy. What is the value they have given? Sigma xx 160 megapascal. Further, what is the value of they have given for sigma yy? It is 40 megapascal. And tau xy they have given 80 megapascal. So what are the yield strength by factor safety? Sigma xx, if you simplify sigma xx plus sigma yy square minus sigma xx sigma yy plus 3 tau xy square. Yield strength, it is 250 by factor safety, that is equal to 160 square plus 40 square, 160 into 40 plus 3 into 80 square. If you calculate factor of safety, you are going to get 1.25 as correct answer. 1.25.
Yeah, rounds are done, right?
Okay, yes.
So, guys, now we will be taking last question from structures module, and this question is from torsion of thin-walled closed structure. Okay, and it was a quite kind of very simple question. So let's see this question. How we can solve. So read the question. What it is given. Two design A and B shown in the figure are proposed for a thin-walled closed section that is expected to carry only torque. Both A and B have a semicircular nose and are made of same material with a wall thickness of 1 mm with strength as the only criterion for failure. The ratio of maximum torque that B can support to the maximum torque that A can support is. So this is what asks. So suppose both the design is subjected to some torque. Okay, so the first design, suppose it is subjected to T max, okay, some torque which is maximum 1, and this design B also subjected to some torque T max 2. Now due to this applied torque, which can be a maximum applied torque, there will be shear flow induced. So this will be like Q1, and there is another shear flow in design B, it can be Q2. Okay, now guys, we know for thin walled closed section, the torsion of thin walled closed section, from Brad-Weather theory, the applied torque T is given by what? 2AQ. Now guys, this shear flow Q is nothing but this is torsional shear stress into T. Now guys, they ask what can be the maximum torque applied. So T maximum will be equal to 2 into A. This A is nothing but cross sectional area. It is what? Cross sectional area, and Q maximum. Now Q maximum will be equal to what? It will be like Q maximum will be equal to what? Tau maximum into T minimum. Okay, so this is what you need to know. That's it in this question. So it is what? Tau maximum into T minimum. Now guys, the failure criteria is what? Strength criteria. So that means the maximum applied torque should be equal to what? Allowable torque. Okay, so tau maximum can be equal to only tau allowable. Okay, so this tau allowable we can find based on different failure criteria. Either it is from Tresca's theory or von Mises theory. Okay, so guys, now this tau max is equal to what? 2a into tau allowable and T minimum. So since thickness is uniform throughout, so it is equal to T. Now what is asked? They asked tau maximum for design B, right? Design B, which is what? Design 2 by tau maximum, which is for design 1. Okay. Now guys, since material is same, so tau allowable will be same for both the design. Now this is what? 2 area. So area of section design 2, and then tau allowable into thickness. Now thickness is also same for both the section, both the design. So it is what? Again 2a1 tau allowable into T. So this tau allowable will get cancelled, thickness will get cancelled, 2 will get cancelled. So this ratio is nothing but area ratio. Now what is the area of design B? So design B, if you look, what is the area? First there is a semicircle, and then a rectangle, and then a triangle. So what is the area? The total area is what? It is pi by 2 r square. So r is what? 1 centimeter square. Then rectangle. So what is the area of rectangle? 4 into 2. Then what is the area of triangle? It is 1 by 2 into 2, which is height, into base 2. So this is what? The area of design B. Now what is the area of design 1? It is a semicircular nose in plus rectangular part. So it is 4 into 2. Now guys, if you find this area ratio, this will be coming to be 1.208969. Okay, so what is the ratio of torque, maximum torque carried by design B to design A is coming as 1.208969. Now guys, if you look into given answer, what is the answer is given? The range is given as 1.20 to 1.22. So the correct answer is what? 1.208969. So this was one of the simplest question asked from thin wall structure. The only thing guys you should know, this tau maximum cannot be greater than tau allowable, and since materials are same, so for both the design tau allowable will be same, and thicknesses are also same and uniform. Okay, so that's all from guys this session, and we'll be starting soon next session, propulsion. Okay, so thank you guys, and for more information you guys can reach on this number or can write mail or visit our website. Admissions are open for gate 2026 and 27 passing students or passed out students, and you guys can also follow us on different social media platform, uh, or you can subscribe on YouTube. You can follow on LinkedIn and other places, or you can join our Telegram group for regular updates and daily quizzes and many more things. So thank you guys. Thank you Rahul sir for your support and time. Yeah.
Yes, sir. Yes, sir. Thank you.
1.265 is not valid for thin walled problem, Sashant. It's not a valid. So guys, those who watch this session, if they like this session, they can thumbs up to this session, or share with your friends. Thank you guys.